Voilà, the floor is yours.
Thank you. Hi, everyone. My name is Isinsu. Today, I'll walk you through our project on tertiary lymphoid structure segmentation using foundation models, which tackles an important problem in computational pathology. Tertiary lymphoid structures, or in short, TLS, correspond to regions that are dense accumulations of immune cells that develop outside lymphoid organs, often in close proximity to tumors. And they are associated with improved survival and response to immunotherapy in various cancers, such as breast or lung cancer. So during drug development and clinical trials, TLS can serve as a predictive biomarker to help identify patients that might benefit from efficient immunotherapy treatment. So I hope by now I convince you that this is an important problem in digital pathology and cancer research. So, however, it's not very trivial. TLS regions can be highly heterogeneous in their spatial distribution and cellular organization. So, ranging from, as you can see on the slide, from early lymphocyte aggregates to fully developed secondary TLS with what's called germinal centers, indicated by yellow here, in their center. So in addition to identifying their presence in what's called histology, these pink images that you see in the slide, predicting their spatial location with respect to the tumor as well as their maturity state is also important for us to understand their impact on tumor microenvironment. So the good news is segmenting TLS regions is feasible on what's called histology images. As I said before, these pink images obtained by scanning tissue specimens removed during a biopsy, because TLS regions have a distinctive appearance on H&Es or histology images. As you can see here, they show up as these much darker clusters that stand against the surrounding tumor regions. And their maturation can also be identified since their appearance can differ from the early stages of TLS. So building on this prior, earlier work has shown that we can capture the spatial and maturation status of TLS from histology images. Current state of the art for automated TLS segmentation is a encoder-decoder architecture that we all know as UNet. That is trained from scratch on roughly 1,000 annotated histology images that come from the TCGA across 3 different cancer types. So this specialist model shows a strong agreement with the pathologist, but still it comes with certain limitations that motivate our project. The first one being its dependency on a large amount of manual annotations, and second one, its limited generalization to new cohorts. So this project asks, first of all, whether pathology foundation models pre-trained in a self-supervised manner can do better in this task using fewer labels. So foundation models, as you all know, have reshaped many other domains, but they are underexplored for dense segmentation tasks. So we want to understand if they can be useful in that regard. If we want to use foundation models, we need to keep in mind that we should divide these gigapixel images into smaller patches, as you can see in the slide, and then extract embeddings for them using the frozen foundation model encoders. In addition to foundation models, we also want to compare 2 ways of aggregating spatial context combined with the embeddings extracted from these models. So the first one being the implicit approach using a vision transformer, and the second one is a graph-based approach that comes with a predefined topology. So we want to understand which one is better at unraveling the spatial context and also while generalizing to new patients. So Janer and I, we're senior researchers in Professor Mariana Rapsomaniki's group at the University Hospital of Lausanne, and we will co-lead this project. So together we bring complementary expertise, machine learning, computer vision, and digital pathology that match the aim of this project. And hopefully some of you who are enthusiastic about this project will also join us. So our project is organized into 3 packages over 2 weeks. In the first week, we will build and compare 2 ways of aggregating spatial context on top of the foundation model patch embeddings. So as I mentioned before, the first one being the cross-attention approach that aims to use vision transformers, learning how patches extracted at different resolutions of the same histology image can attend to each other. And the second one will be a graph-based approach where patches now become the nodes of a graph, and their features will come from the frozen foundation model embeddings. And the spatial context will be learned through aggregating the neighboring information. Let's keep in mind that what we want is more like a clean benchmarking of these strategies on the publicly available TCGA cohort. So even negative results will be very useful since no one before has systematically compared these approaches for TLS segmentation. And if time allows, we will also look into fine-tuning some of these foundation models using, for instance, LoRa approach. Let's continue with the work package 2. So this focuses on label efficiency. We take the best variant from work package 1, retrain it together with the specialist UNet model on progressively fewer label slides to understand how much annotation we can save. And finally, work package 3 will test cross-cohort generalization. So we will evaluate all these models zero-shot on our in-house data set, which focuses on a different cancer type. So finally, a few words on what we're looking for and what you would take away from this project. So we're looking for, first of all, motivated students excited to apply foundation models and computational pathology to a real-world problem to unravel the complexity of tumor microenvironments. So ideally, we expect group members to have solid experience with Python and PyTorch, good understanding with deep learning basics and semantic segmentation. And since this is a fast-moving field, we are looking for people who are ready to get their hands dirty and also try out libraries as they come. So no prior pathology or biology experience is required, so just curiosity, let's say. And you will learn how to handle these massive histology images using libraries like OpenSlide or LazySlide. You'll get to work with transformer or graph-based architectures, which are right at the cutting edge. And you'll see the whole benchmarking and the evaluation process, so from a model on paper to results that you can actually share. So reach out to either of us by email if you're interested in contributing to this project. Thanks for your time.
Thank you very much, Isinsu. So as you heard here, Isinsu is from the University Hospital in Lausanne, which is basically one of the main how to say that, the top hospital in Switzerland. So it's a really nice opportunity for you to work with them. Am I wrong?
Yeah, sure.
Because I've seen the hospital. It's really amazing. It's impressive, and everyone told me about it. Like that's the place to be.
Oh, thank you.
By the way, is there any question?
Maybe a small thing.
Yeah.
The group of crystal that they show is working a lot around those.
Okay, so
could you please repeat the question?
We have a comment here saying that we have a research group working a lot on the exact same topic. They are not here today, but probably highly interested in the project, so we'll share again.
Oh, that's great.
I have a quick question. if anyone is coming with another data set with histopathology or another segmentation task, can you work with both data set, or you're really focusing on this one?
So as a task, we're focusing on. Sorry. No, this is maybe from the room. So we're really focusing on TLS segmentation. And since there are not that many publicly available data sets with annotations, for now we're focusing on TCGA cohorts. But at the same time, we will also have a small amount of labeled histology images from an in-house data set. However, again, there are not that many data sets where we can find the maturation status of TLS as well as the delineated regions available.
Yeah, for sure.
Yeah.
I was asking the question because last year another team was working with histopathology data, so I was just wondering.
Yeah, sure.
Great.
There's an online question, I think.
Yes. Have you thought of using Mamba vision models?
Mamba vision models, you said?
Yes,
yes, indeed, there are some earlier work that use Mamba, especially in the context of foundation models, but maybe as specialist models as well. For now, we haven't considered it, but we are open to ideas. So we expect new group members to also bring their ideas, and if they are feasible during the course of the trail workshop, then why not? We can also take them into account.
Thanks.
Thank you very much. So the next one is Nicola with Project 12. Thanks.
Thanks.